I mentioned in class there's a nice way to derive these formulas for the sum and difference rules for the trig functions. So let's kind of walk you through that really fast. So here are the identities for the sum and the difference of angles for sine and cosine, right? You probably saw these back when you took pre-calculus. A relatively easy way to derive these things is using this identity right here called Euler's identity. Right, Euler figured this out, that e to the I theta is cosine theta plus I sine theta. He figured this out by looking at the Taylor series for these two, or three functions. The Taylor series for e to the x, cosine x, and sine x. A little bit of mathematical manipulation, and you get this identity right here. We can check this out later on this summer when we do Taylor polynomials. But here's how this helps you. So first, you do e to the I x plus y. Right, because this breaks down to cosine of x plus y and I sine of x plus y. Then you examine e to the I x plus y in a different way. Multiply out the exponent, use the properties of exponents to rewrite that this way. Right, those two are equivalent. When you multiply your bases, you add your exponents. Then use the identity for e to the ix and e to the iy. Right, that's e to the ix, e to the iy. Multiply that all out by FOIL. Simplify that because I squared is -1, so it gives you cosine of x cosine of y minus sine x sine y. This is the real part, the part which has no imaginary aspect to it. And the two parts with the imaginary unit I, we put over here. And believe it or not, that's it. We just figured out the rule for cosine of x plus y and for sine of x plus y. Because in this first expression, we have that this equals those two things, where here's the real part, here's the imaginary part. And then we did the exact same starting points in a different way, which gave us the real part and the imaginary part. So the real part, cosine of x plus y equals that, which sure enough is the identity. Cosine x plus y, that right there. Same things. And the imaginary part is the sine, that equals that. This actually was useful to me in the past. I have used this on exams when I forgot the identity for cosine of a sum or difference. You can just do that quickly. This is only for the sum formulas. If you change this to a minus sign, you could figure out the identities for sine x minus y, cosine x minus y. So it's a quick little trick to figure out those identities in a matter of moments.